Hello. In this video, we want to let y equal x squared plus 1 squared e to the 2x. And we want to find dy dx. Okay, so in this one, we have two different functions being multiplied together here. We have x squared plus 1 squared, and then we have e to the 2x being multiplied together. So this is going to use the product rule. So to find dy dx, let's use the product rule. And just a reminder, the product rule would be the y prime would be u v prime plus v u prime. In other words, the first times the derivative of the second plus the second times the derivative of the first. Okay, so let's go ahead and do that. I'm just going to rewrite the first one, which is x squared plus 1 all squared, and then multiply by the derivative of the second. Now, in the second here, we have e to the 2x. The base is e. That means I don't need a natural log as a scaling factor, but that means I can just rewrite it and then multiply by the derivative of the exponent. And the exponent is 2x, so the derivative of 2x is 2. And then plus, rewrite the second, which is e to the 2x, and then multiply by the derivative of the first. Now, notice that the first is x squared plus 1 squared. So we've got something squared, and that something is a function of x. So I need to use the chain rule here. I want to bring the 2 down in front, making that 2, and then rewrite the inside. And then the exponent will be 1, or preferably just don't write it, times the derivative of the inside. And the inside is x squared plus 1. The derivative of x squared plus 1 is 2x. Good. And now we just actually did the derivative. Let's simplify though. To do that, we need to look for common factors. Now, there's a common factor of x squared plus 1 and x squared plus 1. So I'm just going to rewrite x squared plus 1 out here. Now, the lowest exponent is 1, so that's all I'm going to write out here. There's also a common factor of e to the 2x in both of these. And if you look at what's left over there, there's a common factor of 2 both there and there. So I'm going to go ahead and put the 2 right there. And in this first term, there's really nothing else left, so there can't be anything else. So I'm going to go ahead and open a big square bracket. Good. Now let's go ahead and divide everything by this this GCF here. Now notice that the 2 goes away and the e to the 2x goes away. So that and that and that and that cancel each other. But the x squared plus 1 to the second power divided by x squared plus 1, notice we just subtract the exponents. 2 minus 1, and 2 minus 1 is 1. So we're left with, in here, x squared plus 1, and then technically all of that to the first power. But there's no reason to write like that. Good. Now over here, e to the 2x goes away, this 2 goes away, and this x squared plus 1 goes away because this entire thing is 1 in there and 1 there. They're all gone. But notice that we still have left over that 2x there. So plus 2x. Good. Now we have 2, and then x squared plus 1, e to the 2x. And then over here, what we have left over, I'm going to go ahead and put in descending order. X squared plus 2x plus 1. But x squared plus 2x plus 1 can be factored. It's a degree 2 trinomial. And the way that it can be factored is because you can always do it as 2 sets of parentheses. So x and x, same sign, that's what sign they are. So plus and plus. What multiplies to 1 and adds to 2. 1 and 1. But notice x plus 1 times x plus 1 is x plus 1 squared. Now this is what we call a perfect square trinomial. Good deal. And notice that nothing in here is in common with each other, and it's all factored. So hey, guess what? That's pretty much it. So the derivative of y with respect to x here is 2 x squared plus 1 e to the 2x x plus 1 squared. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.